Hi, I'm Alex Kiss, and this statistics video will be on an example of the one-sample t-test. In an earlier video, we covered a summary table on the key ideas and concepts behind this test. I'll review that briefly here. The concept is the mean of a sample is compared to a population mean where the population standard deviation is unknown. The key words and key idea is that the data comes from a normal distribution. The population standard deviation is not known. Therefore, we use the sample standard deviation, which is represented by the letter S. The hypothesis is that H0, the null hypothesis, is that mu, the mean, equals C, some constant, compared to the alternate hypothesis HA, mu is not equal to C. The test statistic is T equals x bar minus mu divided by S over the square root of n. X bar being the sample mean, mu being the population mean, S the sample standard deviation, and n the size of the sample. The example we're going to go over is a measure of how much blood is being pumped out of the left ventricle of the heart. The left ventricular ejection fraction, denoted by LVEF, is known to have a mean value of 58% in the population. You have a sample of 13 patients, shown below, and would like to test if your sample differs from the population mean. Since there is only one sample, we know we're looking at a one-sample test. We know from the literature that LVEF is normally distributed. This is something we can also check using a test such as the Shapiro-Wilk test. Therefore, we're going to consider a test that applies to normally distributed data. When we have normally distributed data, it can be characterized or parameterized by the mean and standard deviation. Therefore, we're going to be using a parametric test. We do not have the population standard deviation, but we can calculate the sample standard deviation from the data that was given. Therefore, we know that we have one sample, the data is normally distributed, and we can calculate the sample standard deviation from our data. We are led to the choice of the one-sample t-test. Hypothesis statement is going to be H0, the null hypothesis, which is the mean mu equals 58, compared to HA, the alternate hypothesis, the mean not equal to 58. The test statistic is going to be T equals x bar minus mu divided by S over the square root of n. X bar, our sample mean, we can calculate from the data given to be 28.7. Mu, the population mean, was given, and that is 58. S, the sample standard deviation, we can calculate from the data given, and it will come out to 10.9. And finally, n, the size of the sample, is 13. Therefore, the result will be T equals 28.7 minus 58 divided by 10.9 over the square root of 13. This gives the answer of minus 9.7. For our example, we know we have 13 subjects. The degrees of freedom for one sample t-test equal n minus 1. So in this case, 13 minus 1 equals 12. A t-value of minus 9.7 on 12 degrees of freedom corresponds to a p-value of p less than 0.0001, which is a highly significant finding. We therefore conclude that our sample mean LVF of 28.7 differs significantly from the population average LVEF of 58. For further information on statistics, feel free to see our other videos, check out our website, or download our Statistics Professor app.